Hi, this is Mr. Max. So I am doing question 7. This question is taken from last year 2023's paper that was written by the AS level learners or candidates in Namibia. So this is also information that can help so many of you as you prepare for the upcoming examinations. Since I'm busy with vectors, I thought let me do the question of last year um, that was based on vectors. So this is paper 1, question 7. So let's just go directly into the question. You see now already circle the question so that you can know which question is it that I'm doing. And towards the end, I will show you also how to use a Casio calculator to find the magnitudes of a vector and also how to calculate the angle between two vectors. Although that Casio calculator is not used in the examination as you are preparing for your exams and as you are preparing for anything within the field, and you do have access to this, it will be immensely helpful also to know that these type of calculators exist. Anyway, they are saying we are supposed to find vector AB, so you have relative to the origin. So from the origin, the position vectors of A, that would be OA, and B, that is OB, are given by 3 in the I direction plus 2 in the J direction minus K minus 1K in the K direction. And vector OB is given by the components of 4I minus 2J plus 5K. Then this is a very important point here. It says that the point C is such that AB is equal to BC, and we're going to use that slightly later. So for 2 marks, they ask you to find vector AB, right? So you should be familiar then with position vectors, that you have a vector AB, for example, then it is the terminal point OB, or the second point position vector, minus the initial point, which is AOA. So the position vector of the second point minus the position vector of the first point. Right. So this is things that you can do. Well, you can write them as base vectors, or you can write them as column vectors. It doesn't really matter. So it's going to be 4I minus 2J plus 5K. Now I'm going to put this one in brackets because it's going to change, the minus is going to change everything in there. OA being 3I plus 2J minus K. Okay. All right. So we can definitely also subtract the 2. So you have got 4 minus 3. Of course, that is just going to leave us with 1I and minus 2. Careful here. So if you were to, like, say, expand, this is going to definitely change the signs. Okay. At this moment, I don't expect to for you to write it out, but you can do that if you want to. I'm just going to work directly from here. All right, so we're then left with minus 2 here. That would be minus 4J. And then you have 5K minus K. So that's the same as addition. And this is the answer. So, well, we can also leave it in column form. And we can accept that as well. So if someone was to write this in column form, which means that vector AB is going to be equal to, so that's 1 in the J direction, it's negative 4, I mean 1 in the I direction, negative 4 in the J direction, and 6K direction. Okay, so any one of these is acceptable. Um, Perhaps something interesting when it comes to this, using that calculator, and I'm going to use this anyway. So if I have vector OB as, maybe I'll just go back up there. So vector OB, so what I'm going to do is I'm going to go to my setup. No, not my setup, but rather if I go to the mode, I choose 8 for vectors. Now, if I decide vector OA or vector OB, which one ever is first, since I have OB, so I'll be choosing this one here. It doesn't really matter. So I'll choose this one to be my vector 1. So I'll say 1 for vector 1. Well, it's a vector in 3 components. So I'm going to choose 1 for that. And I'm just going to input the components there. So 4, it press equal to, -2, press equal to, and then 5, press equal to. Okay, then you can all clear that so the calculator can remember that. And then obviously I'm going to go back to my mode and go back to vector. So I now want the second one, so I'm going to choose 2 for vector B, and it's still a vector in 3 components. So I'm going to input the components there. So it's 3 hit equal to, then 2 hit equal to, and then obviously -1 here, -1 hit equal to. Okay, so I'm going to clear that. So what I did now is vector A minus vector B, so I'm supposed to get the same stuff. So I'm just going to go back and recall them. So for that, I'm going to press shift here and the number 5 to activate that vector over there. So I have got a vector, I'm going to go for 3 for vector A, so that's 3 vector A, and obviously I minus that with hit again the button, vector B being my 4 over there. So what's going to do is going to give me the components. As you can see, I is 1, you can see that. Okay, go to the next one. J is -4, as you can see there, and obviously the K value is 6. All right, so that's how one does that. So those vectors are still sort of embedded within the memory, and I'll continue as I show you how to use and solve other questions using this calculator, although the calculator is not allowed in the national exams. Right. Then when you look at vector, they say find vector OC. So here's a very important concept, and it's the concept that the information we are given is that BC is equal to AB. Okay, so is equal to AB, and that comes from the information right here on top. Say that BC is equal to AB because we know what AB is. Now, what is BC then? So we know that BC is nothing but, if we have to use our position vector, BC is OC, which is the terminal point, minus the initial point, OB. Okay, so we are looking for OC. Looking for OC then, that tells me that you are going to be adding. So it's like making OC the subject of the formula. So A is OC will equal to this BC, vector BC plus vector OB. So this is what I'm interested in order for me to find this particular answer here. So doing that, we know already, um, you know what OB is, and also BC that I have over here. I can replace this BC. So let me just bring a highlighter in here. I'll replace this BC by AB, which is what I calculated before. Can you see that? So everywhere we have an AB, I'll replace it with BC. So I'm going to replace that. So eventually I'm looking at a scenario where I have a condition from here where I say, okay, that is the same as AB, then vector AB plus vector OB should give me OC. And I do have AB and I do have OB as those vectors. So let's quickly go and see what AB is. So we can write it as a column vector, so I'll do that. AB is 1 minus 4, 6. So AB is 1 minus 4 and 6. So we're simply going to add the components together. And OB, again, if I have to go back, as it was given to me in base vectors, OB, obviously OB is 4, -2, and 5. So 4, -2, and 5. So let's go back. That's 4, -2, and 5. So from here, simply for me, a matter of adding. So once you add 1 plus 4, that gives you 5. -4 plus -2, that gives you -6. And 6 plus 5 rather gives you 11. And this is the answer which you can also then write as 5 in the I direction minus 6 in the J direction plus 11 in the K direction. So any one of these is obviously acceptable. Okay, right. No need for me to show you how to do that on the calculator because two things are relatively the same concept. Now, if you go to part B, Roman 1, they want you to calculate. So the thing that I like about these questions is that they are doing it in sort of segments, okay? They're breaking it out as opposed to give you just one big question and ask you to find, let's say, the angle between vectors AB or OA and OB. But in this case, they sort of guide you step by step. So when you have Roman numerals, most of the time, if not always, it infers that whatever you did in Roman 1, that answer is also applicable then in Roman 2. So that is the numbering and the explanation of that. Anyway, in order for us to do the magnitudes of a vector OA, so we're going to take the magnitudes. So obviously, you know, there's a concept of Pythagoras in here. So let me just write down what vector OA is just to bring it back. So let's just quickly go back and see what vector OA is. I'm going to go right so you don't make a mistake. So it's 3, 2, minus 1. So I'm going to write it as a vector. So it's 3, 2, minus 1. So it's 3, 2, and minus 1. So at the end of the day, you use Pythagoras. So what you're going to do is you're going to take the square of that plus the square of that. Here's the thing, you don't have to put -1 here because anything you square will be positive anyway. But if you wish to, you can put that negative over there and then you can calculate this out. So obviously it's going to be the square root, I mean the 3 squared is 9 plus 2 squared, which is 4. Again, -1 squared is going to be 1. Everything is positive. So this gives you 14, which is the square root of 14. Just an interesting fact there, because I want to show you how to calculate the magnitude of that vector using this calculator. So just say, what is the square root of 14? Well, the square root is something like 3.741. So I'm going to have a 3.741, for example. So this is about 3.741. Well, I'm not going to use this when I continue in the second part. I just want to show you how one can find that. So let me just go back to my calculator and vector OA. So if I have to go back, shift vector, I think it was vector because I had OB minus OA, so I think it was vector 3. So let me just quickly hit enter and see. So that's 4, -2, 5. So that's not the one. So let me go back again and see. So I think it was vector B. So I'm going to have 4. Let me see. Okay, so of course it was 3, 2, -1. So it's vector B. Right, so now that I know it's vector B, so the way I'm going to find the magnitude using the calculator, you go to shift and then you press the absolute value, the ABS button. Can you see that? Okay, so you shift to activate those sort of yellowish or whatever color you see there. In that case, we said that was vector B, so I have to go back to go and get my vector B. That was represented by 4 over here. Right, so if I then close this down and I hit equal to, can you see that you are getting the magnitude? Of course, it's not insert form, but it's the decimal value, whatever the case may be. Okay, just an interesting fact. And let's do the second one. Again, let's have vector OB over here. So vector OB, remember in the exam, you are not allowed to write on this margin over here. It is where the examiners are marking. So let's just find the vector OB. Let's go back all the way to the question. So vector OB is 4 minus 2, 5. So I'm going to write that as a column vector, 4 minus 2, 5. So that is 4 minus 2 as well as 5. All right, so let me then just work it out. So again, the magnitude of vector OB using obviously the concept of Pythagoras, you're just going to say 4 squared. Again, you can just press 2 squared here, without putting the minus in brackets, you can get the same answer. Of course, just to have it out there, I'm going to leave it like that, and then plus 5 all squared. So everything over here, so let's see, we have 16, that is 4 squared, 2 squared is 4, okay, and 5 squared is 25, and we're going to continue. So that's 20 here plus 25, so 20 plus 25 is nothing but the square root of 45. Well, I can also go ahead and just write that and simplify that further. I know 45 is nothing but 9 times 5, so I can separate this as the square root of 9 times the square root of 5. So eventually it gives me 3 root 5. Okay, now it doesn't really matter. At this instance, you could have also left your answers as root 14 and root 45, or whatever the case may be. It will still be correct to do so. Just to see what the 3 root 5 or root 45 is on the calculator. So if you have root 45 on the calculator, so you get something like 6.708. So it's about 6.708. So let's see. So this is about 6.708. So I just want to show you when I punch that onto the calculator. Of course, I just have to make sure. I think this one was my vector A. So if I have to recall it on the calculator, shift press 5, that was my vector A. So I'll choose 3. Vector A, let's just hit enter. You see that it's 4, of course, and negative 2, that's what I have there, and 5. So that is vector A. Now, so if I want to find the magnitude, so I'll be saying, let's just go a little bit up. So you can see that I get the 6.708. So I'm going to recall, I'm going to say, first I'm going to say shift the ABS button, the absolute value, the magnitude, and shift again to go vector A, then I'll choose 3. Of course, you can now press equal to, can you see that you get 6.708, which is the equivalent decimal value of that answer that is insert form. Okay, right. Anyway, I will suppose that for these questions, you leave your answer in set form, okay, because you're still going to continue with these answers in part B, Roman 2. Right, so let's go to part B, Roman 2. Using a scalar product, find the angle between vectors OA and vectors OB. Now, very important concept. Of course, you know that in order for you to find the angle, you'll have to say cos theta. It's going to be, obviously, if I have to use the formula, it's vector A dot vector B, or the product of that, not the product, but the dot product of that. And that is going to be divided by the magnitude of vector A times the magnitude of vector B. So in our particular case, our vector A will be represented by our value of OA. So we already have what our OA is. So I'm just going to write that. Our answer will be cos theta will equal to, it was OA, vector OA dotted with vector OB, and that should be over the magnitude of vector OA, which we calculated before, multiplied by the magnitude of vector OB. So it's just a matter of us finding the dot product over there. So if we have to take the dot product, of course, of these two, okay, I can also use the calculator for that, but I'm just going to show you how to do that. So OA in vector form was nothing but 3, 2, and negative 1. And dotted with OB was nothing but 4, negative 2, and 5. So please just go back and check so that you can see whether you're on the right path. So I did write those vectors here. Okay. So now when we find the dot product, so remember, you multiply and add the components. So it's the sum and the product of the components. So you'll be say 3 times 4. So I'm going to write it down. So it's 3 times 4 plus 2 times negative 2 plus negative 1. So I have negative 1 times 5. So we can find whatever that answer is. So 3 times 4, that's obviously 12. So let me just write it down. Negative 2 times 2, that's negative 4. And negative 1 times 5, that's negative 5. So this is like 12 minus 9. So this answer is 3. Okay, so that's the dot product. That will be what comes in the numerator. So actually we can actually complete it because we already have the magnitudes of vector OA and vector OB. So my angle then is cos theta is equal to that 3 over the magnitude of OA. So that means we have to go back to my magnitude of OA that I calculated, which was root 14. So I'm going to put root 14 here. So root 14 over here. And that's multiplied, of course, by root well, I will take the other one, 45, as opposed to 3 root 5. Totally up to you, same value. So root 45. Right. So whatever this answer is, now if you have to find the angle, you have to take the inverse cosine of the answer that you get. So please make sure that your calculator is set in degrees mode, okay, so that you don't get a wrong answer. So let's grab our calculator and see. So this is what we expect in the examination. Please go ahead and it's still, you see that D that is there, it's highlighted for degrees mode. So inverse cosine of 3 upon, you have maybe I'll say root 14 times root 45, and I'm going to close it. So just the way I use my brackets, so just have to close there, and I open a bracket here, so I need to close a bracket down there again. Anyway, that gives me an angle 83.135, so it's 83.135 and so on, some odd degrees. So you are always told in front of this question paper that if your angles are in degrees, just go back to the instructions or information to candidates. Here they say give angle, these answers, and let's just highlight that so you can know which part I'm using. Give answers for angle sizes to 1 decimal place. Okay, so these angles are in degrees, not radians. Radians will be 3 significant figures. So that means I have to give this answer over here to 1 decimal place. So that's going to make it 83.1. Okay, so that is 83.1 degrees, of course, to 1 decimal place. Right, so it's basically how it's done. But let me just show you how to find these using the calculator. So I'm going to start all over, clear everything, so you have an idea. So I'm going to decide that from here, my vector OA, which is 3 minus 2 minus 1. So I'm going to say, okay, set up, or the mode, I'm going to change it to vectors. Okay, then I'm going to decide that vector OA, which is my 3 to negative 1, is going to be represented by vector A, so I'm going to hit 1. And it's a vector in 3 components, so choose 3. I'm going to enter those components, that is 3 equals to 2 equals to negative 1. Okay, 3 to negative 1, well, you can clear, say all clear. And then I'm going to go again back to the mode, and I'm going to choose 8 again. So I'm going to choose vector B, that is number 2. And it's still a vector in 3 components. So it's 4, negative 2. So it's 4 equal to negative 2 from here equal to, and then 5 equal to 4, negative 2, 5. Okay, so now we know what the vectors are, and we can directly find this. So I will say I'll first find this particular answer, which is this one that I highlighted here, but it will be some decimal value. Okay, so I don't want to do inverse cos over here yet. I just want to find this on the right hand side. So it's going to be vector A dotted to vector B. So I'm going to recall. So I'm going to go shift, press 5 here. So vector A was represented by number 3. Then shift again, go back there. You see that 7 for dot product. So press 7, dotted, shift again. So I'm going to go back to, and that vector B was represented by 4. So let me just do something. Let me just put the stuff in brackets because I'm not done. Since I still have to divide that by the denominator. So I'm going to again open a bracket. So now we're going to look for the magnitude of vector A, and that I said you must press shift the ABS button for the magnitude, and we want vector A, so shift again, we go look for vector A, which is represented by 3 over here. So that calculates the magnitude of vector A, and that should be multiplied by the magnitude. So shift ABS, and then shift, go back for vector B, which is represented by 4. So I close that. So just remember how many times did I open the bracket. So I open it here, so I need to close it back there again. Now if I hit enter or equal to, I get 0.1195. So what that is this value over here. Is this value over here. That is 0.1195 and so on and so on. So what I will now do is I'll say shift to show you what the angle is. I will say, okay, shift the inverse cosine of this answer. The calculator remembers it. Okay, and then you press equal to. Can you see? You get the angle as easy as that. All right, so it's just for interesting purposes that I'm using that calculator to show you. Of course, you still have to do this stuff without using that calculator. So that's question 7 on vectors, on 3D vectors, that was asked in last year's paper.